Sir, this is my response to you, showing you why you're wrong. So pretty much I just rewrote everything you wrote in your video to me, and why you're wrong and why I'm right. So up here, I have what you start off with. It's not focusing. Anyway, yeah, one quick note. You had a negative sign here instead of a plus sign. That's the first error, but it doesn't really matter for the whole proof thing we're doing right now. So we had this and this. This is where, like, in your video at least, the actual important stuff of your response was. So first issue I see with this one is that I'm assuming that you try rewriting this equation to this equation and from this equation to this equation. This equation is not the same as this. These are similar. Actually, no, they are equivalent. Actually, these first two are equivalent, but this third one is not equivalent to these two. Reason why? So if you go here, this is partial y, partial z, and p. This is partial p, partial y, partial p, partial z. If you rewrite this in a similar way as this, you're gonna get partial y, partial z, p squared. You're getting a p out of nowhere for some reason, which is not the same as that. That's the first issue with this. And the second issue with this thing is, even if these equations were true, this wouldn't follow from all this stuff. Reason being is because it's not possible for this and this to not equal the same thing. Reason being is that these are actually the same value. To show you why, I'll go here. So if you had a equation like this at first, it's like pi I hat, and then qr j hat, and then actually that's plus sign, and then r k hat. So this is let's assume that this is a gradient of some function f. Okay, so if we all know that the gradient f is equal to d, partial f partial x, and then it would be, and then partial f partial y, then partial f partial z. All right, this right here is equal to not q. This is equal to p. This is equal to q, and this is equal to r. So if you go up here, take these equations, these values, plug them into these two things, and this applies to all three of them, but I'm just focusing on these first ones right here. If you put this p into this right here, you're going to get you're pretty much going to get the same thing. You're going to get df cubed, actually, respect to dx dy, and then yes, so no, not cubed, it's squared, sorry. So this is what this goes into this. If you plug in this into that, you're going to get that, right? Now if we plug in q into this one, guess what we get? We get partial squared f dy dx, and they're actually the same thing using Clairaut's theorem, or whatever's their theorem. So that's why these must be the same value, and it doesn't make sense to say this is equal to 0 and this is not. So that's why your response is wrong. I wasn't really looking at the camera this entire time, so I might have not shown you what my work was, but here's a quick thing. You can stop the video anytime, get a quick look at my work. Yeah, that's about it.